The only thing that matters is the music. Boom, boom, boom. Okay, hash 21, right? Okay, so what we want to do is, I don't know. I think this one's going to be fundamentally different. Because we're not going to have a grid. So we're going to go new brick. It's going to return a vector 3. Bum, ba, bum, ba, bum, 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 ba, dum. So what we want to do is so as we go across in the X row, what we want to do is, see, like this would be 0, there would be a boundary, and then this would be 1, and then there would be a boundary. Okay, so let's see if we could just alternate the colors and do the boundary, because the boundary is the number one thing, pretty much. So how do we do the boundaries? So we have to have a minimum and a maximum for each little spot. It doesn't really matter if you multiply the UV or whatever, but the only thing that should be even, let's look here. The only thing that should be even is the Y, and then the X is random. Okay. So that helps me. So, like, let's say we have 10 randoms. Then we want to know what's the highest of the 10 that it's less than to determine the color. So we can just loop through. Oh, okay. Hold on. So let's make a loop. And let's just say 32. Oops. Excuse me. So and then we're going to go like this. Int y equals int float, or no, int floor. We're just going to use GL point chord, really. Dot y. So, oh wait, we're not going to floor it, are we? No, hold on. What are we doing? So we're just going to use GL point chord dot y. And then we're going to divide it by, because it's going to go from 0 to 1, right? So we want to put up, let's say, 10 layers. And that's going to be even, or however many layers we want. We can go grid size right here. We can actually do grid size that way. What did we do before 8? Let's do 12. Grid size, okay. So then we're going to divide by grid size for the y. And it's not going to be an integer, it's going to be a float. I don't know why I'm thinking that. Okay, so y divided by grid size. Okay, there we go. So those are our rows. And then let's take 1.0 divided by 32. 0.03125. Okay. We just want to know the maximum through here, so let's go int m for maximum is equal to 0. Okay. If uv.x is less than I times 0.03125 times I, then the maximum, m, is equal to I. So after that loop runs, we will know where we're at on the loop there. Excuse me. And then what we're going to do is GL point chord y. Okay, so if, wait, what's this UV, Jeff? GL point chord dot x. If GL point chord, or let's just go, this is easier, back to UV equals GL point chord. UV dot y is less than y. UVY dot grid size. But we want to know where we're at on there. We actually just want to know the division of that, UVY dot y. So we're going to get a number here. So int y2 is equal to uv dot y divided by y. And that's going to give some number, like 0 to grid size. So then we're going to floor that. And then we can take the integer of that, which will give us the actual integer for the level that we're at. Then we're going to go if y2 mod 2 equals 0. Then our base color, okay. We're going to go base color equals color 1. Else base color equals color 2.
This is ludicrous.
Everybody likes State Farm. We love it. It's fine. Especially that Jake from State Farm, right? Okay. Base color equals color 1. Base color equals color 2. So then X just determines... So M determines the shade of the thing? I don't know. I don't know what I'm doing. Anybody else know what I'm doing? I don't know. So let's go with the shade. So, excuse me. So, and it's going to be up to 32. So let's just go with a shade like this. So base color times equals. And we have to make this a float because the M is an integer. So float M divided by 32. Or actually just no, wait. What are we doing? 32, so M is... Why do I do this? So if uv.x is less than I times 0.03125. M equals I. But then we just want to multiply it out here by point. And then return the base color. Does that work? New brick. Let's see. Error. Okay. Line 84, 87, 95. Got a lot of errors here, Jeff. How you doing? Unexpected that. Undefined variable grid size. Wait, what have I done wrong? Something completely wrong, probably. Oh, because it's not a float. Oh, we didn't get errors. Oh, it worked? So the y divided by... There's 12? No, there's not 12. What did we do? What have you done? How many lines did we get? Let's leave out this part. Weird. Okay, not what I was going for at all. So all I want to do, Jeff, all I want to do is as we go across. Dun, 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 dun. First of all, let's do the, let's start again. UV equals point chord. Float. Bum, 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 da, da, bum, bum. if uv.y, okay. What was it? UVY divided by... So grid size, let's say it's 12. We take UV... Oh, see, that doesn't give it to us. It's almost easier if we multiply this by grid size. Excuse me. Because then if our grid size is 12, we're going from 0 to 12. 0 to 12 on the Y. So then we just go... We can just go floor of uv.y. Int floor of uv.y. Okay, mod with 2 equals 0. Then we can do a base color. Can we do that? And it'll... No. Let's just take out all the rest of this. Wait, can we undo that? Okay, this is where we should start. And then we need the border, so... We don't even see that. There we go. Actually, would it be helpful if we go like this, return vector 3, 1? No, it's just white. Okay. Computer. Okay, so that takes care of the border. So, assuming that we're not in the border, so, and if we wanted to use, okay, so what I did previously was I was using the coordinate system to put a border in at every fractional, just like with the y, right? So if I want to do that here, I just go like this, fractional part of uv.x greater than 0.9, just start there. And that will give us a grid. But what we want to do is on the x-axis, on the x part right here, this is going to be a variable amount. So let's just go And we've got it going from 0 to 12, right? So we just want to choose, let's just try first choosing one random number between 1 and 12, and we'll put it in there. So in this case, how would that work? We have n11, which takes a float and returns a float. We also have hash 21, which takes a vector 2 and returns a float. I think we want this one, hash 21. So with this one, why don't we send in so the variables that we have here for the y, int floor right here. So the y coordinate, okay, hold on. So for the hash, I forget the variable, the function name now, hash 21. All right, copy this, take it down with you. Take it down with you. Excuse me. So instead of this, we're going to use this. And we want to send in a vector 2. So we want to send in the y variable there. So let's go like this. Let's change this. It's going to be int floor. Oh, so let's just go float y floor equals floor uv.y. Okay. I mean, we can leave that there, but I'm just going to swap it right there. So then down here, we can go vector 2p. We're actually going to send in some x and then y floor. Because y floor is already each one of those levels. Okay, good. So the x that we want to send in is going to be just the only thing we have is just uv.x, right? Wait, how do we do this when we keep track? Because, like, say the first one we're going to get is 0.3. So then for the first 0.3, that's going to be a color. We shouldn't use the UV, we should use the GL point for it. But did I multiply it up here? Yeah. Excuse me. Okay, so then right here we're just going to use uv.x, but that's going to change with each pixel. How do we get this random value for the first one? How do we know how many random values we're going to have? How do we do that? All right, first time we're using Bing in a while. Here we go. Excuse me.
I'll have the avocado toast minus the avocado.
So
Another ad. Oh my gosh. Hold on. That's what I get for not using video game music. Alright. I'm trying to make a row of bricks on a point. I'm sure that I've thought about this before, but let's see what it says. A noise function. Right. Okay. Takes a vector 2, returns a float. I got it. Okay. Brick size. Calculate the brick size. Number of bricks. Calculate the position within the current brick. Output color. Check if the position of the edge of a brick. This will create a row of bricks across the x-axis with random sizes. The rand function is a simple hash function. Generates a pseudo-random number. Got it. Okay, so brick size equals 0.1 rand GL point chord times 0.2. Random size between 0.1 and 0.3. Calculate the number of bricks. Floor GL point chord dot x divided by the brick size. Calculate the position within the current brick. Good try. That was very close, but not a cigar. I see. You want each brick to have a unique size. In that case, you want to use a 1D array to store the sizes of the bricks. However, GLSL does not support dynamic arrays, and the size of the array must be known at compile time. That's fine. Here's an alternative approach using a fixed size array. Maximum bricks 100. Brick sizes. Initialize brick sizes. Brick sizes equals that plus that. Random size. Oh, wait. You're right. Calculate the current brick index and position within the bricks. Okay, this is what I want to do. Yeah, so I just want to use an array of sizes. Right, there we go. So let's assume that the most we're going to get in here. Well, we could do that, but let's just go like this. Let's think. So what if we want, like, how many bricks going across? Hold on, we can do this. Initialize, okay, brick sizes. Float brick sizes, max bricks. So really all we're calculating here is the edges. That's what we need. That's what I needed. Okay, so let's go up here. Colors, point chord, whatever. Okay, so hold on.
Everything changes.
Brick edges, we're gonna go float. Okay, and then so for each one of these times, every time through, so we just want to use the N11, am I right? But we can use hash 21 because we're going to have a different Y for each one. Okay, great. So hash 21. Hold on. Stop it. Stop thinking. So the brick edges sub I is going to equal hash 21. We send in a vector 2. That vector 2 is something comma y, or y, which is, excuse me, y floor. And then the x is the I. And do we need to make that a float? There we go. So the brick edge is that, okay. And then it's hash 21. So that's going to return a value between 0 and 1. And then what we want each time is for that value to be at least, let's say 0.5, so 0.5 plus hash 21, which is there, parentheses there, parentheses there. Okay, and then we're going to multiply that by 0.5. We don't even need the array. We don't need the array. Bum, bum. We just want to find the maximum index. Hold on. And then with that, we want to okay, hold on, no. Int m is the maximum index. So if uv.x is less than that, then we want to go m equals I. Float hash 21. Okay, all this we don't. Alright. We can still leave that in because that's the. Or no, if you. Fractional part of x is greater than. No, we don't want that either. But what we want is. So uv.x is less than 0.5 plus hash 21 times 1. Then m equals I. So m is going to go from 0 to 11, whatever. And then we want to just apply that m divided by 11 to the color. Okay, hold on. Return base color times float m divided by 12. So the first one's 1. uv.x is less than 0.5 plus. Okay, hold on. Does this all need to be in parentheses here? Is there any errors? There's no errors. 0.5 plus this. The reason we're not saving it is because we're just going to calculate it each time anyways to compare it, so it doesn't matter. Dun, 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 dun. Dun, 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 dun. Oh, but wait, look. Oh, wait, we do need to save it. Hold on. That's what's going on. It's working. I just didn't notice. Alright, well that makes it a little bit easier. Hold on. So then we need to know that as well. So brick edges equals that. If uv.x is less than brick edges
Open
sub
an
I.
account with a trusted global broker and trade cryptos and FX.
Alright, whatever. For the sake of the music, I should have just let it go. I know, but whatever. I don't. uv.x is less than brick edges, then m is equal to I. So that will tell us which one. So isn't it equal to the previous brick edges? So the first time it goes through brick edges 0 is equal to brick edges. Oh my. Because it's cumulative as we go across. So bridges I is equal to that, but then you have to do another loop inside the loop. Okay, hold on, no. That's kind of interesting. J is less than I. J plus plus. So brick edges sub I. Excuse me. We're going to say at the beginning of the loop, they're all going to start out brick edges sub I is equal to 0. And then we're going to add this. But each time we run this, we want to do float J. So the first time it'll be 0, then it'll go 0, 1, and add them up. Okay. And then so that'll definitely be bridges. Okay. Oh, there we go. But what did we get? So all it's calculating is for each row, we're getting return base color times float M divided by 12. If uv.x is less than brick edges I, M equals I. And each time M starts at 0, so it's going to go up. So base color, float M, and we don't have an edge. If the fractional part of uv dot, okay, hold on, right here. So the edges need to be calculated there as well. Interesting. So let's also, up here, let's set a max bricks. Let's go with 16. Oops. What just happened? L value in array access to complex. L value in array access? Oh. Can we go like this? Now what's the error? Non-constant expression. Okay. So max bricks equals 16. This we'll have to set manually there as well. That's fine then. Okay, that gets us further along, but... Okay. So I don't think that this is working as I intended. Because m is some value between 0 and max bricks. Which should mean that the base color is multiplied by, and it should get dimmer as it goes towards the end. Which it looks like it just goes 1 until it gets to the end when it's 0. So, I know that I can do this. We're close. We're very close. What happened to the chat? Calculate the current brick index and position within the brick. If position in brick is greater than position in brick minus brick size index, brick index plus plus. Output color. Check if the position is the edge of a brick. If position in brick... oh, we have to find the position in the brick. The position in brick is greater than brick sizes brick index minus 0.1. Brick edge color, brick color. Oh. This code creates an array of brick sizes, each with a random size between 0.1 and 0.3. It then calculates the current brick index and the position within the brick by iterating over the array and subtracting the brick sizes from the x-coordinate until it becomes less than the current brick size. The color is then set based on whether the position is at the edge of a brick or not. Please note that this code assumes the total size of all bricks does not exceed 1. The range of GL point toward x. If the total size can exceed 1, you will need to add logic to handle this case. Okay. So we want to try this for just one row, right? This is a random vector 2 returns 1, so that's fine. Define max bricks. Oh, let's use this. Hold on. Before we go any further, let's use this. Why don't we actually learn from the AI, Jeff? Can we do that? So where is that defined? Is that defined outside of any functions, computer? So there's a function, then there's inside. Okay, so we can put it anywhere outside of the function. So new brick, yeah. So let's put it out here. Max bricks, we're gonna go with 16. Okay. So now we don't need this. Whoops. Underscore. Okay, I got you. I'm with you. So does that break anything just putting that in? No, okay, that's good. So the next thing, float brick sizes max bricks, which we have, right? Brick edges. So initialize the brick sizes. So let's try this. Actually, hold on, let's... Hold on. Initialize the brick size. Let's just copy that in. Brick sizes. For int I equals 0, I is less than max bricks, I plus plus brick sizes sub I equals 0.1 plus random. Okay, so in this case we're not using random. And it's going to send in a vector 2. So we're using hash 21, and let's get rid of this while we're up here. Okay, hash 21. Where are we at? What's going on? What's happening? Okay, so vector 2I times 2 random size. Okay, so that'll do that, right? Calculate the current brick index and position within the brick. So brick index equals 0, position in brick equals gl.cord.x. While position in brick is greater than brick sizes, position in brick minus, that's cool. Doing it, we're doing it. That's what we need. That's what I was missing. This proper calculation. Let's just keep going. Output color. Check if the position is at the edge of a brick. Output color. If position in brick is less than that or that, then we go with the edge color. So we're going to discard there. Otherwise, we'll use the brick color, which, okay. We just need this, I believe. And then we want to discard, so hold on. We can safely replace this with that. So position in brick, color equals, this will just discard. Brick edge color. Else, color equals base color. Hey, what's up? Fifth, what's up? Where did you guys come from? I heard fifth function and then I see this here. Follow age. I don't know how long you've been following. Following since almost a month. What's up? I'm deep in thought. Not really. How you guys doing? So base color, a fractional, so we don't need this anymore. And then return base color, I don't think we're doing that. I think we're discarding or return base color right here. But we still need to modify it based on, but we'll cross that road when we come to it. Oh, look, it works. Except for it's not different for each one with each Y level. However, if we use, where's the hash 21? Where's it at? So max bricks, hash 21, I, comma. Didn't I still have the floor Y? Yeah, or Y floor. There we go. Hey, we got it. I just got it. What's up, guys? Almost a year. Oh, almost a year? Are you serious? Oh, bro, thank you. What's up? Oh, I didn't check my years. Oh, I'm an old man. I can't believe I just got it. You guys just got here just in time. Do you know how many 49 minutes of struggling, of binging? Just kidding. I just got it with help of Bing. I should have listened to Bing all along. So this is really cool, except that this kind of looks a little awkward. But I guess not really. And what I want to do also as we go along, brick edge color. Hold on, let me look here. So check the position, edge of brick, position in brick, brick sizes, brick index. Brick sizes, brick index. Okay. So return base color. So right here we also want to... So brick index is an integer, so is max bricks. So do we still have access to that brick index? We do. Base color times. And I think we've got N11. And we're just going to put in float. Will that work? Interesting. There we go. All right, that's cool. Interesting. So how come the initial float brick index can we make that a little bit more of an interesting number?
Apple Gift
A
Card
little
is
bit.
a practical gift that unlocks the world of entertainment and fun. You can send it via email or give a physical card to your loved ones. Your friends and family can spend it on their favorite Apple services, including Apple subscriptions. Apple Gift Cards can be used to buy all things Apple: products, accessories, apps, games, movies, TV shows, iCloud Plus, and more. Visit apple.com for
I'm
details
still not
and to send
satisfied.
Apple Gift Cards to your friends and family this holiday season.
Let's try this. Hold on. Am I hearing an ad right now? Yeah, I'm on Google with my or YouTube with my no copyright electronic dance music. That bum, 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 bum. Am I hearing an ad right now? That's hilarious. Bum, bum, bum. So let's use vector 2. So what's the vector 2 we can throw in here? Brick index. Let's go with a brick index. Alright, I'm lost in parentheses right now. So float brick index, comma floor y. And floor y is a float, right? Hold on. Y floor, excuse me. Okay, so parentheses, vector 2, parentheses, hash 21, parentheses, 0.5 plus hash 21. There we go. Break anything? That's better looking. That's better looking. That's a lot better looking. And then we can dim it down a little bit more. That's a little bit more random. I like that. Hold on, I think it's a little too... Hash 21. Is this the multiplier right here? Yeah, so let's go times, because we're going let's go times 0.7. There we go. And if we don't want them to top out too much, I think what we can do here is 6. Give it a little bit more randomness. Okay, that looks good. Now, if we want more bricks, let's see if we can go 0.5 here and times 1.5. Yeah. Is that better? That looks cool. See, I was kind of going for this. See the bricks here? Something like that. So this is a function that'll basically give you... We can do other parameters and stuff too, but that is really cool. We got it. Okay, so... Jeff, you're crazy. So let's go here. Save that. Okay. So what did I call this one before? New bricks 1. So let's go here. Let's go new bricks 2. Click outside. Click there. Okay. And now let's replace this garbage with the actual new brick just in case. Go back here. Did I get a screenshot? Screenshot. Okay. Just in case for the screenshot, let's go with purple and yellow. Oh, that's cool. And then what if we want new brick 12, huh? Because Y is, what is Y? Base color, Y floor, base color set Y. So let's just go up to 18. Oh, it does. Automatically does. That's cool.
5 function. This is my old brick shader. 5 function. Link to brick function.
This is my old brick shader. Oh, cool. Hold on. Doom GPU update. Oh, dude, look at this. Oh, this is cool, dude. Wait a minute. Do I have this saved? Hold on. Everything is paused. Wait, press pause break? What's pause break? How do I get out of this? Refresh. Da-da-da-da-da-da. I'm surprised this works on my GPU. That's cool. Dude, this is so cool.
Like you, be strong to hold the powers of the sun.
Bum 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 bum.
To dream, believe in strength. Now I'm the only one. Only one.
5 function. It turned out better than I remember.
I was an ordinary
Allow, deny, the last. Oh, the F? Okay. The ground was my try for water. Oh, the wood turned out better than I remember. Last in the F. Okay, cool. Dude, that's awesome. This is so cool. I got the bricks. Yes. Okay. Alright, well, I'm going to try to keep my videos short, so I'm ending it here. Do we got enough to do a raid? I guess 2 is a good enough for a raid. I don't even know who's on. Let's go see. Who's good? Who's on Quantum? Well, we're going to Quantum then real quick. let's go to Quantum after his whatchamacallit.
5 function. You can see my code if you remove the last thing in the URL.
Doesn't even show it. Come on, computer, you know. Tum apprentice. There we go. Have we got people? Because I'm just going to end it. I'm going to throw this up on YouTube.
All pixelated looking. 5 function. GG.
Alright, say hello to Quantum.